Exactly. All right, so today we're looking at percent increase and decrease, which is just really subtracting and dividing numbers, but you just have to be careful. So is the percent used to compare changes in quantity? Oh, I probably have this here, don't I? Look at this little dot hiding there. Haha. Figured I wouldn't be having to write that out. See it light up.
Yeah, I just write the percent, so you put, you guys write the whole thing.
You can put whatever you want in. These are your notes, Aaron.
Because I put that.
I was worried about it. I had trouble sleeping last night.
I just love waking up to text from your parents saying you have a 2-hour delay. They're like, you don't even care in the first place. You just sleep in no matter what. If you drive.
And then there's two formulas for percent increase or decrease, which is the amount of increase over the original amount, or the amount of decrease over the original amount. Now, if you only have to remember one formula, you can calculate the amount of increase or decrease through subtraction, right? How much did it increase, how much did it decrease, just by subtracting the two numbers. So if you want, instead of these two formulas, you can write down this one, which is the large number minus the small number. But the big thing is that the denominator has to be the original number. And then this is one formula you can use for both for any of the problems. Yeah, probably. You're never going to have a negative, so because we write the word decrease instead of a negative. So you'll take the larger number minus the smaller number, divided by the original, whatever the original cost or population or whatever was, and then we will write the fraction as a percent. So we'll actually divide them, bless you, and multiply by 100 to get our answer as a percent, increase or decrease. We don't have a lot of questions. This is good. So the first one, we have a graph given to us from the year 2000. The most recent thing we ever solved. It was approximately 6 billion at the time. And they want us to find the percent increase in world population from 2000 to 2150 using the high projection data. Okay, so the high projection data you can see is the top one. So its prediction is 30 million at the end. At the beginning, they tell us that it was 6. Okay, so again, we're going to do our large number minus our small number all over our original number. And don't put over small or large because that will change depending if it's a percent increase or decrease. So this will be 30 minus 6. Now what goes in the denominator, the 6 or the 30? 6. What came first? The 6 billion. So we'll get 24 over 6.
Why are we doing 4? Why isn't it 30 minus 4?
Because the original population was 6 billion.
I didn't read that.
Yeah, and then they put this little arrow there because it's kind of hard to tell if it's 5 or not. And then we'll divide this and we will get 4. Now you have to change this to a percent, so you actually have to multiply this by 100, so it really increased by 400%. If you don't want to have to write increase, you can just put like a little up arrow next to it instead of writing the word increase. Part B asks us to find the percent decrease in world population from 2000 to 2150 using the low projection data. So again, we're going to do our large minus small all over original using the low projection data. So the two numbers are 6 billion and 4 billion. So again, we're going to actually put 6 billion first. The original number, though, was 6. So we'll get 2 sixths. And we can take our calculator. We should know that's 1/3, but 2 6 gets me 0.3 repeating. And then again, I have to multiply that by 100 to get it in a percent. So this should be approximately 33%, or we could even put 33 1/3% if you want to be accurate. And this would be a decrease. The only way you can really screw it up is if you put the wrong number in the denominator.
Might be the rock.
For security purposes, Aaron. Alright, a jacket regularly sells for $135. The sales price is $60.75. Find the percent decrease. Find the percent decrease. So we'll do our large minus small all over the original. So the large number is 135. The smaller number is 60.75. Which number goes in the denominator? 135 was the original selling price. Subtract, divide, and change to a percent. It's getting too warm in here.
Yep.
It hit the threshold. It's peaked, I'm sorry. I didn't set the timer.
There's the one-handed spin.
Yeah, crank it.
So it should be a 55% decrease. It just changes so fast.
What the
From cold to hot.
temperature?
You're gonna put me to sleep here.
It does. Alright, last one. Tomatoes at Giant Eagle cost 25 cents. Due to bad weather, the tomatoes now cost 33 cents each. Find the percent increase. So see if you guys can try that one.